Hello everyone, welcome back to our subject Modern Operating System and Computer Networks. So myself Dr. Madhivanandare, currently working as an assistant professor to the Department of School of Computer Science and Artificial Intelligence in SR University at Warangal. Coming to the today discussion is based on in the network layer. In the last lecture we was discussed about IP version 4 and today we will discuss about this IP version 6. IPv6 addressing and address space, then transmission from IPv4 to IPv6. So why we shifted to IPv4 to and IPv6 we will discuss in the next slides. What is mean by IPv6 address overview? So as we know in the previous lecture I was discussed about this IPv4 IP address. So coming to the IP address version 6 is upgraded internet protocols. It designed to meet the growing demand for IP addresses that IP addresses cannot be handled due to its limited address space. So it overcome the issues of IP address version 4. What are the issues? Like it cannot handle due to its limited address spacings. So due to limited address spacing, it should be shifted to the IP version 4, 6, but the basics from the IP version 4 only. So it provides a system for identifying and locating the devices on network and routing traffic across the internet. So it should be identify the locating devices on network and routing traffics. So it will get the traffic's clearance for that transmitting the um, frames to one to another and identify the locating the devices also through the internet. So coming to the key features of IP version 6 model. So IP version 6 version 6 uses a 128 bits addresses compared to the one IP version 4 32-bit addresses. So it's very high bit when compared to the IP version 4. So it providing an almost unlimited number of unique IP addresses because the bit size is too high, 128 bits when compared to the IP version 4. So therefore, it provides unlimited number of unique IP addresses for the devices. So it written in hexadecimal and separated by colons. So like as we know in the previous lecture we discussed about this what is the meaning of hexadecimal. So hexadecimal it's nothing but the containing of numbers from 0 to 9 with a to f of letters. So that's why here saying it's using hexadecimal with separated by colon like this one, and it consists of 8 groups like 8 group each represents 2 bytes, like 8 groups here, 2 3 4 5 6 7 8, like 8 group it represented by 2 bytes 16 bits, and each hexadecimal digits equal 4 bits 1 nibble. So groups are separated by colon. So why we need for the IP version 6 model? So IP version 6 was mainly introduced to solve the IP version 4 addresses depletion caused by the rapid growth of devices, especially ITO and to improve the why we need for this one to improve the efficiency and support multimedia and enhance the security purpose as well. So in the key features including like large address space can also possible and particularly 128 bits addresses can be provided whereas 32 bits for the IP version 4. So versatility increases available addresses and better header format. So base header separated from optimal fiber, optimal file field and speeding up to routing. So while separating the headers from optimal field, the speeding of routing should be enhanced. Thereby, the data transmission should be very faster. So now optimal, sorry, the next we will optimize and establishability. Now we got optimization and extensibility like allows additional functionalities and features of protocol extensions. Then resources allocations. So new field traffic classes and flow label. The flow label of data should be enabled. Special handling for real-time audio and videos, managing how network bandwidth and priorities as well. Based on the bandwidth and priority, the audio and video should be uh, transferred without any traffic of a very flow smooth, with a smooth manner. And it enhanced security purposes. So coming to the enhanced security purpose, it built in encryption and authentication ensures confidentiality and integrity by means of the data should be encrypted before transmitting to the one to another as well as the authentication also ensure confidentially for no one can access the file. So without authentication the file should not be read. So here the two purpose will be activated. One is encryption, decryption, and another one is the authentication purpose as well with integrity. The next is addressing method. Supports a unicast and multicast method and analytical anycast methods. So in that IPv6 addresses format and the notation, how they were written and notation as well. So in the previous slide I discussed like it should be like a hexadecimal format should which means the numbers with letters. So here the format like a 128 bits should be which equals to 8 times of 16 bits groups. So by the simplifications rules like the rule one drop leading zeros from this by the so hexadecimal format it should be leading zeros drop the leading zeros then should be results converted like that. So here should be C. And the rule number two is collapse one consecutive sequence of all zeros groups. Then rule number three is all zero expect last bit one semicolon. The colon should be colon one. So coming to the addressing methods, so there is a three methods addressing method in IP version 6 model. So the one is the unicast method. It identifies a single device's packets are delivered to that one specific interfaces. So which means it will identify the unique IP addresses to send the file to that unique addresses with delivered to that one specific interfaces. The next one is a multicast method. So it identifies a group of devices. Packets are delivered to that all the member of the groups in simultaneously. So which means it should be identify the group of the IP addresses, group of the devices. The packets are delivered all the members of the groups simultaneously should be like from the one organization the message should be distributed to the all the workers at a simultaneously, we can call it like that, or mail. Then next, anycast address. So addressing to the multiple devices, packets are delivered to the nearest device in a group. So who are nearest to the device, the packet should be delivered to that devices in that group. So in that IP version 4 model, there is a 4.3 billions only limited capacity of IP addresses can be used, whereas IP version 6 340 undeclaration possibility can be achieved. So in that methods like unicast and multicast and anycast, there are three fundamental address types are replaced from that IP version 4. As we said, like unicast, broadcast, or multicast models. Coming to the unicast, identify the single interference packet delivered to the exact one destination. So, like a global unicast, routable one internet, and link local and same link only, like that we should be distribute the or share the frames and data. Then transmission from IP version to IP version 6 key mechanism. What are the key mechanism while transferring or shifting to IP version 4 to IP version 6? The migration from the IP version 4 to IP version 6 requires a strategic approaches that ensure the capability while wireless, enabling the gradual adaptation across the diverse network interferences infrastructures. So, it requires strategic approaches that ensure the compatibility while enabling a gradual adaptation across the diverse network infrastructures. So the transition must be smooth to prevent any problems between the IP version 4 and IP version 6 systems. So here the three strategies have been uh, devised for the transitions purpose. So one is a dual stack method and a tunneling method and a header translation methods. One or all these three strategies can be implemented during these transition periods. So coming to the dual stack methods, so the internet cannot be switched overnight. So why we shifted, as I explained. So internet cannot be switched overnight. So thereby the three strategies manage this coexistence. Coexistence. So it preferred for dual stack method. So both protocols run in simultaneously on the same devices. So IP version 4 and IP version 6 are both can be run simultaneously on same devices. So devices are both like IP version 4 and IP version 6 addresses and choose protocols based on the destinations for so where should we reach go for the data. The destination should be important based on the selection of the IP address versions. And most widely deployed it today for these methods, and no packets conversion needed for this kind of using dual stack methods, and used by most modern OS and routers for this dual stack method, because if in case of use for the ipv 4 can also possible in case of want to IPv 6 model to use execution that transmission can also be possible at the same time simultaneously. So the next one is a tunneling method, bridge method, we can say. So IPv6 packet encapsulated inside IPv4 packets. So IPv6 packet equal payload of IPv4 packets. Then travels through the IPv4 infrastructures and then types of 6 in 4 and 6 to 4 and Terado and ISATAP. So then the transparent to IPv6 endpoints. So used where dual stack not possible. So wherever the stack method is not possible, then we can use this bridge stack methods or tunneling method. Then next one is a translation NAT64. Like IPv6 only host communication with IPv4 only host. So translate IPv6 addresses in both IPv4 and IPv6. So NAT64 plus NDS64 mechanism were used. So it allows IPv6 only networks. Headers field are mapped. So finally, the end states translate method. Translation method. So coming to the dual stack method, we can discuss here deeply. Like devices simultaneously run both IPv6 and IPv4 protocols, allows a seamless communications with both addresses type without requiring direct mappings. So it recommended that all hosts before migrating completely to version 6 have a dual stack of protocols during the transmission. So in other words, like a station must run IPv4 and IPv6 simultaneously until all the internet used IPv6. So all the systems are used if comes to becomes comes to IPv6 until we can use it IPv4. So here is a simple working method of how dual stack method should be work. So the most natural IPv4 and IPv6 transaction run both the protocols side by side. Like here is a IPv6 packet and IPv4 packet also simultaneously can run both as protocols side by side. So side by side can run in. So here I have written like each interfaces get both IPv4 and IPv6 addresses, then DNS resolver returns both IPv4 and AA for AAA and A for IPv6 records. Then OS prefer IPv6 if destination has IPv6 addresses. So OS will decide if it is IP address should be 6, it should be uh, applicable for executions. Then if it fails backs to the IPv4 if IPv6 unreachable. In case of any failure in the IPv6, it go back to the IPv4 model to use the purpose. So no translation, native performance on. Coming to the advantages of dual stack methods, no translation overhead and gradual non-destructive rollout and works with all modern OS as well. Then challenges are like it requires IPv6 infrastructures and high memory configure overhead, and IPS must support IPv6 routings. Otherwise, it go to the IPv4 model. So then the second category is like a tunneling methods. So tunneling like is a strategy used when two computer using a IPv6 want to communicate with each other, and the packet must be passed through the region that uses IPv4. So for example, here the two packets are in the two IPv6 model. In okay, with each other one, and the packet must pass through the region that uses a IPv4 region. So to pass through this region, packet must be have a IPv4 addresses. So once the data to pass through this tunnel, it must be have IPv4 to use the two IP addresses at sender to receiver side. So the IPv6 packet is encapsulated in IPv4 packets when it enter the region. So when it enter the region, it encapsulated to the IPv4 packets, and it leaves it capsule when it exit the region. So up to here, it should be capsulated. When it's a end to the exit to the tunnel, it should be go to the IPv6 models. So it seems if the IP goes through a tunnel at one end to and emerges at the another end, to make it clear that the IPv4 model packet is carrying an IPv6 packet as data, the protocol's value is set to for 1. So like here packet email examples like a header sends IP addresses, receives IP addresses, protocols, packet members like a 90 to 96 bits, and payload data should be 896 bits, and trailer like data of so and end of the packet error correction should be 32 bits. So head translations like her header translation. So a header translation is necessary when the majority of the internet has moved to IPv6, but some systems still use the IPv4. So which means the entire system should not depend on the IPv6 model. So in case of we will use for the IPv4 models. So the header translation is necessary when majority of the internet has moved to IPv6, but some systems still using a IPv4 models. If the sender want to use IPv6, but the receiver does not understand the IPv6 model also, that cases we have to use it the IPv4. For. So tunneling does not work in this situation because the packet must be in the IPv4 format to understand by the receiver. In the cases, the header format must be totally changed through the header translations. So the header of the IPv4 packet is converted into the IPv4 headers. So here is a host of IPv6. Then in case of the system should not hold or some like it should be like some system like still not in the IP does not understand the IPv6 model. So in the cases we have to use it IPv6 region as a tunnel region, then header translated done here like converted to the IPv6 IPv4 header to payload region. So NAT 64 translation here addresses translation mechanism converting IPv6 version 6 addresses to the IPv4 addresses, which enabling the IPv6 only devices to communicate with the legacy of IPv4 thus for host transparently. Then map E and map T techniques. So mapping of addresses and port Encapsulation map E and translation map T enables IPv4 services to operate the effectively over the IPv6 more infrastructure network. So the tunneling carrying IPv6 over the IPv4 like IPv6 headers, then payload as IPv6, then ncaps surfaces use IPv4 header and again IPv6 header for receiver side. So common tunneling type 6 in 4 like protocol 41. Manual configure like IP6 encapsulated in IP4 with protocol field like a 41 static endpoint and 6 to 4 RFC 3056 automatic uses of uses a 2002 colon by 16 prefix. So IP version 4.6 addresses enabling in IP version 6 for addresses. So next Tedro and IS ATAP intra-site tunneling within an origin. So IP version 4 addresses appending to 5EFE prefix. So translation NAT64 and DNS64 like a common workflow. This is a common workflow of IP version 6 host to IP version 4 servers. Initially 6 version and DNS64, then NAT, then 4 IP version 4 to server. So how should we work? A NAT64 gateway has pool of IP version 4 addresses and map incoming 66 version ESS SAR addresses to an IPv 4 addresses, which translate the IPv 6 head file to IPv. So these are the some comparison between the IPv 4 and IPv 6 models. uh, protocols versions like 4 and 6. So address length should be as we know 32 bits and this is 128 bits and address notation like we can use a decimal notation dot dot in between these binary bits and is a hexacolon. Hexadecimal with the colons we can use it and total addresses like 4.3 billions and 3.4 times of 10 over the 38 and header size like 22 to 60 bits of variables. Here is a 40 bytes fixed. Then fragmentations like routers and a host, then source here is a source host only and broadcast like yes here is a now replaced by multicast, then security IPSs like optimal and mandatory optional and mandatory here, then auto configuration manual and dynamic and stateless auto configuration, then NAT requirement usually yes and no larger address space. Coming to the summary, so from this lecture, we learned what is the IP address version 6 and what is the size of the bits and what is the format like hexadecimal with the with the colon. These are the format. So, like 8 groups of 4 digits, leading zeros drops and replaces consecutive 0 groups and address space 2 power of 128 and equal to 240 undeclined addresses undeclaration and versus 4.3 billions of IPv4 addresses can be possible And address types like a unicast, one to one, and multicast like a one to many, and anycast one to nearest. So no broadcast in IPv6 model. And a header improvement like a fixed 40 bytes headers, no checksum methods for error analyzing, and no fragmentations by routers, and flow label of for key, and extension headers for options. And then dual stack like run IPv4 and IPv6 simultaneously. OS picks best protocols while running the uh, transmitting the data. Most widely developed transitions methods today. And coming to the tunneling, WAP IPv6 packet in IPv4 for large networks types of like a 6 in 4 and 4 to 4, 6 to 4, and Tetra, and IS80AP. And the translation like a NAT. That's it. Thank you very much. See you on the next lecture.